Welcome to Maths World YouTube channel. Today we will discuss types of matrices. Before starting the video, press the bell icon and subscribe my YouTube channel to get new and innovative videos about maths. Types of matrices. Number 1, row matrix. A matrix is called row matrix if it is only have one row. So this is the definition of row matrix. So just mark it out up till row here that row matrices is a matrix which has only one row. Example, a matrix M that is 2 minus 1 7. So just see this example, it is having only one row. And order, it can be asked in the MCQ. So what is order? Order is this. This is actually one. One should be on the place of rows. Then column matrices. A matrix is a column matrix if it has only one column. This is the definition. Mark the definition of the column matrices. Then if you just see example also, so M has having only one column, then N also having one column. Then it is rectangular matrices. Rectangular matrices in which the number of rows are not equal to the number of columns. In this example A, if you just see, so how many rows are there? 1, 2, 3. And how many columns? 1 and 2. So they are not equal. In B also there are 2 rows and 1, 2, 3 columns. And here also just see 1 row and 3 columns. In option D, there is only one column and how many rows? 1, 2 and 3 columns. So it means the orders are different. So it means that the rectangular is a matrix. A matrix is rectangular matrix if the number of rows are not equal to the number of columns. Highlight the definition and write one example along with it. Then square matrices is a matrix. Square matrix if number of rows is equal to the number of columns. Number of rows are equal to the number of columns. It is a square matrices. If you just see in example A, there are 2 rows and 2 columns, then 3 rows and 3 columns, 1 row and 1 column. The order is written respectively. Now, if you just see, these are the 4 types. Next, we will move to the other types so that we can learn them. So if you just come here to the 5th type, that is about the null matrices. Matrix is called null matrix because all the entries are 0. If you just see in all the matrices, the entries are carrying the 0 number. And they are represented by O. When we people don't know that, this is very important. Ask MCQs also that, but how is it represented? They are represented by capital O. That's not 0. Then transpose of a matrix is how can you find a transpose? Is a matrix is obtained by interchanging the rows into columns and columns into rows. Interchanging the rows into columns and rows into columns. Columns into rows and rows into column, and A transpose is its symbol. If you just see what you will do, that the entries which are in rows. If you just see here 1, 2, 3 in matrix A, just see I will highlight. In matrix A, the entry 1, 2, 3, 1, 2, 3, these entries 1, 2 and 3, they are in the form of rows, but in transpose they are come into the column. Then 2, 1, 0, it is also in the row, it next it change into column, it will write in the column entries. Then -1, 4, -2 is also in the row, and we will write it into the column. Just like that, the entries which are in rows, suppose 1, 2, 3 which are in column we have written, okay, just which are in column 1, 2, -1. So 1, 2, -1 is into the rows. Column entries are in the rows and rows entries are in the column in the transpose. Just like B also and C also. This is a exercise question. So do practice that how you are going to change them. There is a let negative of our matrices. How you are going to take the negative of the matrices, that a square matrices let A matrix then A negative. What you will do, that you are going to in a matrix, suppose this is matrix A, so you are going to change the entry signs. If the sign is in plus, so minus and into plus. Suppose 1 is in plus, so negative transpose negative of matrix will be -1, -2 will be changed into 2, and 3 will be changed into -3, and 4 will be changed into -4. Then is a symmetric matrix. What is symmetric matrix? Is a square matrices, number of same. Square matrix, you know, the number of rows and columns are same if it is equal to the transpose. Transpose. It means that the transpose is equal to the original matrix. Suppose this is example to you that what happened that when you take the transpose, because the rows and column as a square matrices, rows and columns are the same. So when we'll take the transpose, it will equal to the same matrices which we took the transpose. Okay. Now we will study the skew symmetric matrix, which is equal to negative of the transpose. When you're going to take the transpose, that will not be your A matrices but negative to the A matrices. Now this is the diagonal matrices. A square matrix is called diagonal matrices if at least one of the entries of the diagonals is not zero and non-diagonal are zero. Just understand this concept. You know how the diagonal are. This is a 1 2 3. These are the diagonals. So what you will do, that these diagonal 1 2 and 3, 1 2 2 0 1, these are at least one diagonal entries. आपको पता है diagonal कैसे बनाए जाते हैं? बिल्कुल इस तरीके से, ये ऐसे करके diagonal यूं करके बनाया जाता है. I'll show you from the note mark. Okay, how can you make the, okay. So if you just see now, 1, 2, and 3. This is actually the diagonal. These 1 and 2 and 3 are the actually the diagonal. This 1, 2, and 3. Actually, this is the diagonal. Okay. ये diagonal होगा आपका 1, 2, and 3. Okay. Have you understood? कि this is 1, 2, and 3. These 1, 2, 3 are the diagonal. Next, what you will do? Just see the diagonal entries 1, 2, 3 are non-zero. They are not zero, and non-diagonal like 0, these all the non-diagonal, they are 0. Diagonal entries are 0, like 1, 2, and this 1, this 2, and this 3. These are the diagonal, they are not 0, and non-diagonal like 0, 0, these are non-diagonal are 0. Okay, next is the scalar matrices. Scalar matrices are the matrices, they are the matrices if all the diagonal entries are same. Their diagonal entries are same and non-zero. Their diagonal entries are same and non-zero. Their diagonal entries are same and non-diagonal are non-zero. So let's see the diagonal entries. Scalar matrices, the matrices, their diagonal entries are same, like k, k, 2, 2, 3, 3. These are the scalar matrices. The last term, which is about the identity matrices, all the diagonal entries are 1. So this diagonal, this is diagonal. So 1 1 1 1. So now last important point of this topic as scalar and identity. What are scalar? Scalar are the matrices in which the diagonal entries are same, and identity matrices where the diagonal entries are 1. So they are diagonal. But all the diagonal, what are diagonal? They are not scalar entity. Diagonal entries, if you just remember that they are those entries in which the diagonal entries are not 0, and non-diagonal entries are 0, and the simple no. Again, diagonal entries are non-zero, and the non-diagonal entries are 0. That's not scalar and comp. So just remember it for your concept questions. So learn the definitions and practice. That will be help you in exercise 1.2. So practice, and if you have any question you can ask me at the end. Do like and subscribe my YouTube channel. Thank you so much.